The National Electrical Code, or NEC, provides guidelines for the safe installation and operation of electrical systems, including standby generators. When installing a new generator, it's crucial to comply with these requirements to ensure safety and prevent hazards. Let's address the two questions concerning the disconnect breaker location and the need for mechanical interconnection. Concerning the disconnect breaker location, NEC Section 700.23 mandates that the generator disconnect be accessible to the generator. Accessible, in this context, generally implies that the disconnect should be within sight or within easy reach of the generator. This requirement ensures that in case of an emergency or during maintenance, personnel can quickly and easily disconnect the generator from the electrical system. However, there is an exception to this rule. NEC Section 700.23b exception allows the disconnect to be located up to 50 feet away from the generator, provided that two conditions are met. Firstly, the disconnect must be visible from the generator's location, and secondly, the disconnect must be under the exclusive control of qualified personnel. The visibility requirement allows personnel at the generator location to visually confirm the status of the disconnect, whether it is open or closed, providing an additional layer of safety. The exclusive control by qualified personnel ensures that only authorized and trained individuals can operate the disconnect, preventing accidental or unauthorized operation. Given this exception, it may be acceptable to locate the disconnect breaker for the newer generator in the existing panel next to the older generator, even if it's in an adjacent room. However, this is contingent on meeting the two conditions stipulated in NEC Section 700.23b exception. The panel must be visible from the location of the newer generator, and only qualified personnel should have access to the panel. If these conditions are met, the remote location of the disconnect breaker would be compliant with the NEC. Now let's address the second question regarding mechanical interconnection. NEC Section 700.23c addresses the need for a means to selectively connect and disconnect all phases of the generator output from the premises wiring. This requirement is in place to prevent the simultaneous energization of the system from multiple sources, which can lead to dangerous and potentially damaging situations. The code mandates that there must be a way to prevent both generators from being connected to the system simultaneously. NEC Section 700.23c2 provides two options for achieving this. The first option is mechanical interconnection, which involves connecting the breakers in such a way that only one can be closed at a time. This can be achieved through various mechanical interlocking mechanisms that physically prevent the simultaneous closure of both breakers. When one breaker is closed, the interlocking mechanism prevents the other breaker from being closed, and vice versa. This approach provides a positive and reliable means of ensuring that only one generator can supply power to the system at any given time. The second option is automatic means, which involves using a device that automatically disconnects the first generator when the second generator is connected. This can be achieved through the use of automatic transfer switches or other similar devices. These devices monitor the status of the generators and the electrical system and automatically switch between the generators as needed. When the second generator is connected, the automatic transfer switch automatically disconnects the first generator, preventing simultaneous energization. Therefore, it is mandatory to have either a mechanical interconnection or an automatic means to prevent simultaneous energization of the two generators. In situations where switching between the generators is performed exclusively by trained and authorized engineering personnel, a mechanical interconnection may be the most practical and cost-effective option. A mechanical interlock provides a simple and reliable way to ensure compliance with the code, preventing accidental or unauthorized simultaneous energization of the generators. In summary, when installing a new generator, it is essential to comply with the relevant NEC requirements to ensure safety and prevent hazards. The disconnect breaker should be accessible to the generator either within sight or within easy reach, or it can be located remotely if it meets the conditions outlined in NEC Section 700.23b exception. Furthermore, it is mandatory to have either a mechanical interconnection or an automatic means to prevent simultaneous energization of multiple generators, as specified in NEC section 700.23c. Compliance with these requirements ensures the safe and reliable operation of standby generator systems. Now let's delve deeper into each of these code sections, providing a more comprehensive understanding of their implications and applications. NEC section 700.23 focuses on the accessibility of the generator disconnect. The primary intent of this requirement is to ensure that in case of an emergency, such as a fire or equipment malfunction, personnel can quickly and easily disconnect the generator from the electrical system. This allows for the safe isolation of the generator, preventing further damage or hazards. The term accessible is intentionally broad to allow for flexibility in different installation scenarios. In some cases, the disconnect may be located directly adjacent to the generator, making it easily accessible. In other cases, it may be located slightly further away, but still within sight and easy reach. The key is that personnel should be able to quickly locate and operate the disconnect without any obstructions or difficulties. NEC section 700.23b exception provides an exception to the accessibility requirement, allowing the disconnect to be located remotely under certain conditions. This exception recognizes that in some situations, it may be more practical or convenient to locate the disconnect away from the generator, such as in a centralized control room or electrical panel. However, to ensure safety, the exception imposes two conditions. The first condition is that the disconnect must be visible from the generator's location. This allows personnel at the generator location to visually verify the status of the disconnect, ensuring that it is open before performing any maintenance or repairs. The visibility requirement also provides an additional layer of safety in case of an emergency, allowing personnel to quickly assess the situation and take appropriate action. The second condition is that the disconnect must be under the exclusive control of qualified personnel. This ensures that only authorized and trained individuals can operate the disconnect, preventing accidental or unauthorized operation. Qualified personnel are typically electricians or other trained technicians who have the knowledge and skills necessary to safely operate electrical equipment. NEC section 700.23c addresses the need for a means to selectively connect and disconnect all phases of the generator output from the premises wiring. This requirement is in place to prevent the simultaneous energization of the system from multiple sources, which can lead to dangerous and potentially damaging situations. When multiple generators or other power sources are connected to the same electrical system, it is essential to have a way to ensure that only one source is supplying power at any given time. Simultaneous energization can cause overloading of the system, damage to equipment, and even electrical hazards. NEC section 700.23c2 provides two options for achieving this selective connection and disconnection. The first option is mechanical interconnection, which involves connecting the breakers in such a way that only one can be closed at a time. This can be achieved through various mechanical interlocking mechanisms that physically prevent the simultaneous closure of both breakers. The interlocking mechanism typically consists of a series of levers, rods, or other mechanical components that are linked together in such a way that when one breaker is closed, the other breaker is physically prevented from being closed. This approach provides a positive and reliable means of ensuring that only one generator can supply power to the system at any given time. The second option is automatic means, which involves using a device that automatically disconnects the first generator when the second generator is connected. This can be achieved through the use of automatic transfer switches or other similar devices. Automatic transfer switches monitor the status of the generators and the electrical system and automatically switch between the generators as needed. When the second generator is connected, the automatic transfer switch automatically disconnects the first generator, preventing simultaneous energization. Automatic transfer switches typically use sensors to detect voltage and frequency levels and logic circuits to control the switching operation. They can be programmed to automatically switch between generators based on various criteria, such as power outages, voltage drops, or generator malfunctions. In addition to these specific code sections, there are other relevant considerations when installing and operating standby generators. It is essential to ensure that the generators are properly sized to meet the load requirements of the facility. Overloading a generator can cause it to overheat and malfunction, leading to power outages and equipment damage. It is also important to regularly inspect and maintain the generators to ensure that they are in good working order. Regular maintenance should include checking fluid levels, inspecting belts and hoses, and testing the generator under a load. Furthermore, it is crucial to provide adequate ventilation for the generators to prevent overheating. Generators produce heat as they operate, and if the heat is not properly dissipated, it can cause the generator to malfunction. Proper ventilation can be achieved through the use of fans, levers, or other ventilation devices. Finally, it is essential to follow all applicable local and national codes and regulations when installing and operating standby generators. These codes and regulations are in place to ensure the safety and reliability of electrical systems. Now consider some practical examples of how these code sections might apply in real-world scenarios. Firstly, consider a hospital that relies on standby generators to provide power during power outages. In this scenario, the accessibility of the generator disconnect is of paramount importance. The disconnect should be located in a readily accessible location, such as a nearby electrical room or hallway, so that hospital staff can quickly disconnect the generator in case of an emergency. The hospital might also choose to install automatic transfer switches to automatically switch between the generators and the utility power. Secondly, consider a data center that requires uninterrupted power to maintain its operations. In this scenario, the data center might choose to install multiple generators to provide redundancy. The generators would be mechanically interconnected to prevent simultaneous energization. This would ensure that only one generator is supplying power at any given time, preventing overloading and equipment damage. The data center might also choose to install a remote monitoring system to monitor the status of the generators and the electrical system. Thirdly, consider a manufacturing plant that uses standby generators to power critical equipment during power outages. In this scenario, the manufacturing plant might choose to locate the generator disconnect at a centralized control room. This would allow plant personnel to remotely disconnect the generator in case of an emergency. The plant would ensure that the disconnect is visible from the generator's location and that only qualified personnel have access to the control room. The plant might also choose to install a backup generator to provide additional redundancy. The information provided should assist in understanding the NEC requirements for standby generator disconnect locations and the need for mechanical interconnection. By complying with these requirements, one can ensure the safe and reliable operation of standby generator systems. The use of qualified personnel is also extremely important. Remember that electrical work should be performed by qualified and licensed electricians.